Hello, welcome back to General Chemistry Foundation channel. Today we will discuss on quantum number. So first of all, in quantum mechanics, it has 4 quantum number that are required to describe the distribution of electron. The quantum mechanics can be written as N, L, ML, and also MS. So let's see what's the meaning of all these terms. N is principal quantum number, L is angular momentum quantum number, ML is magnetic quantum number, last one is MS, electron spin quantum number. Without further ado, let's go details on each of the terms. We begin with N. N is principal quantum number. To make you easy to understand, N is the integer number. So N must be begin from number principal quantum number 1, 2, 3, and etc. So you can see here we have a proton and the outer layer is electron. So the first shell we call as N equal to 1. The second shell is N equal to 2, and the third shell is N equal to 3. Next, we go for L. L means for angular quantum number. So the value for L is related with N. The value must start from 0 to N minus 1. If you can see here, if let's say we have N equal to 1, L must be 0. If N equal to 2, we have L is 0, starting 0, and N minus 1, meaning that 2 minus 1 is 1. So for N equal to 2, at shell number 2, we have L is either 0 or 1. Same as N equal to 3. When N equal to 3, the L value is 0, 2, 3 minus 1 is 2. So starting we have 0. Next, before reaching number 2 is number 1, 0 or number 1 or number 2. Basically, L is referred to shape. If L equal to 0, the shape is S. If L equal to 1, the shape is P. If L equal to 2, the shape is T. And L equal to 3, the shape is F. So we have S, P, D, F. Now you're done with L shape. Now we begin with ML. ML is the value from negative L to positive L. So if let's say you have L equal to 0, the value for ML is 0. If the L equal to 1, the ML is negative 1, 0, and plus 1. Why this thing happen? Because the ML itself must lie the value from negative L to positive L. So L equal to 1, the ML is negative 1. We have 0, and after 0 is positive 1. Okay, next we look for example L equal to 2. If L equal to 2, ML must be negative 2 until positive 2. So negative 2, after negative 2 you find the value negative 1, after negative 1 0, after that positive 1, and lastly is positive 2. So meaning that all this value is lies from negative L to positive L. By the way, the ML is basically showing you the orbital diagram. If ML is 0, okay, only have one value, so you have only one box. If ML, we have 3 value here, 1, 2, 3, negative 1, 0, and plus 1. So we have 3 box. And for L equal to 2, ML, we have 5 value here, so it has 5 box. And again, if you can see what I wrote down here as, and this S only 1 box, p orbital only 3 box, and d orbital 5 box. This is because this one is ml is actually referred to the value of L. So therefore, you have to recap back L equal to 0 S. That's why S only 1 box, and then L equal to 1 is referred to p orbital. So p orbital, it has 3 box, and L equal to 2 is referred to d orbital, and d orbital, that's why it has 5 box, referring to ml value. Last but not least is ms. Ms refer to spin. The value for spin only has 2 values, either positive half or negative half. If you can look at the example here, we have 1s, so on the arrow upward, the orbital ms has positive half value, and if the arrow spin is downward, ms value is negative half. I hope you can understand all 4 of the set quantum number. Now, let's look out for the example. So this is the question. Show set of the quantum number that describe the unpaired electron of 1s2, 2s2, and 2p5. Because the question asking on unpaired electron, you just refer to 2p5 by drawing the orbital diagram 2p5. Before we have discussed, p orbital has 3 box, so you have to fill in 1, 2, 3 and return back 4, 5. So you can see here the unpaired electron on this last box. So in order to give the set quantum number for this, so you have to write down first N, L, ML and MS. N is principal quantum number. Because it has 2 here, it means that this one in shell number 2, you write number 2 here. And L is refer back to N, but because we have p orbital here, p orbital is 1, the value is equal to 1, so write down 1. And ML is referring back to L, so because L equal to 1, ML is negative 1, 0 and plus 1. So because the unpaired is in the box of plus 1, written here 1. And you look up here, the orbital is upward, so the ms will be positive half. Okay, that's all about the quantum number. I hope you really enjoy and understand this video. For the next video, you can open to www.openlearning.com and enroll course General Chemistry Foundation channel. Thank you.